All right. In the last video, we talked about star-forming regions that have pillars and columns and spires and globules, but not all star-forming regions will have those things. Some are young and they just haven't had a chance to form them. The hot gas hasn't had a chance to expand very far and create these structures. Or maybe the region's driven by just a single star, maybe a low mass, low luminosity B star, and it just doesn't have the oomph to create these magnificent structures. Anyway, some star-forming regions exhibit different properties, and these properties are connected to dust. And here's a great example. This is the Trifid Nebula. And on the left, we have an optical picture, and on the right, we have an infrared picture. And these are not made with Skynet. These are made with other facilities. So what do we see? There are two types of dust here. There's line of sight dust, dust that's between it and you along the line of sight. And there's dust that's just a little bit off the line of sight. Let's start with the line of sight dust. So here we have our emission nebula. That's the H2 region. There's stars in there that are heating and ionizing the gas. It's glowing pink because of Balmer emission. But we see this dark stuff around it. That's just dust in the surrounding cloud. And it's between the source of light and not. Sometimes we see dust in other parts of the image. Like you may see a region that's missing a lot of stars. That's dust as well. But this dust is backlit by the star-forming region. So it really stands out. And it looks dark at optical wavelengths. But if you turn on your infrared layers and the dust is close enough to the stars, the same stars that are heating the gas, if the dust is close enough, it will be heated too. And here you see the dust glowing in the infrared. For example, you may see this in your Spitzer 8 or your Weiss data. Okay, so that's one type. The other type has to do with this blue emission, reflection nebula. This is also caused by dust, but dust that's not along the line of sight. So let's look at a diagram of this region as viewed from the side. So here we have the cloud that's forming stars. This part over here has collapsed, made some stars. It's creating the H2 region. Any dust that's here will be that line of sight dust that's dark at visible wavelengths, but if it's close to the action, it will glow at infrared wavelengths. But here we have a cloud of dust. It's a little bit disconnected, and it's not along the line of sight. It's floating up above or below or to the left or the right. And light from the star-forming region, the H2 region, goes in all directions, not just to our eyes. Some will go up into this cloud, and that light will be scattered by the dust. Dust scatters light, and it scatters blue light preferentially. It's kind of like our atmosphere. We have stuff in our atmosphere, particles that scatter blue light preferentially, and so the blue gets scattered all over the place. And the red mostly goes through. That's why when you look at a sunrise or a sunset, you're looking through a lot of atmosphere when it's low on the horizon. The red light comes through, but more and more blue gets scattered out. Same thing here. The red light's going through, but the blue light gets scattered everywhere, including into our eye. And that's what you see here. We call that a reflection nebula. That's dust in a cloud that's not on the line of sight. Now, sometimes these clouds are close in which case the dust is close and will be heated and glow, and sometimes they're farther out. In this case, this reflection nebula does not have an infrared counterpart. So it's a cloud that's too far away to be heated by the stars. So you can see by looking at this in different wavelengths, you can start to draw conclusions, paint a physical picture. Here's an example of a reflection nebula that is warming its dust. This is, of course, the Horsehead Nebula over here. And back here, we just have some Balmer and some S2 emission. And this is line of sight dust blocking it. But over here, this is NGC 2023, if I remember the number correctly, and it's a reflection nebula. There's a star in here, and the light is, well, it's passing through the dust, and the blue light's getting scattered at us. Now, if we turn on the infrared layers, you get something like this. The dust that's here, this darkness, you see it's glowing. Not the head of the horse. So the horse is probably foreground. That dust is far enough away from the source of the heat that it's not glowing in the infrared. But this dust is. It must be closer to the source of the heat back behind it here. Over here, you're getting a lot of infrared. So this is a reflection nebula, but that dust is close enough to that star that it's glowing pretty significantly in the infrared. So again, you can start to piece together a story. Okay, I'll stop this video here.